Welcome to the Institution of Agricultural Engineers Landwards 2020 conference. I'm your host for today, Andy Newbold, editor of the institution's magazine Landwards, and I am joined today by Professor Simon Pearson, who is a director of the Lincoln Institute of Agri-Food Technology at the University of Lincoln. Now, Simon will be talking to us today about lean digitised agriculture. Over to you, Simon.
Thanks, Andy. It's a great privilege and honour to be speaking to you today. And so I'm going to give an overview of what we do at LIAT and where we think the direction of agricultural technology is going, particularly agricultural engineering in terms of digitisation and some of the lean design principles that we're using. So Andy's asked me just to give a little bit about my background as an intro, but my background is really from family farming, and shown by the picture on the left. My father was a vegetable farmer in South Lincolnshire, so I grew up on a farm and seeing things like that every day, and that's a harvesting rig of cauliflower cutting, and that process hasn't changed in the last 35 years. I then moved off to University of Reading, where I did a PhD in crop science and engineering, so I was split between the plant sciences school and the engineering school at Reading. Worked a little bit at Reading, then I moved on to M&S, where I was a technologist, working in really looking after their cut flour supply chain in terms of technology aspects. Then I left M&S 2005 when I worked for a company called Winchester Growers, and we're very big farmers. We had 4 farms, 2 in Lincolnshire, 1 in Cornwall, 1 in Portugal, and we grew an awful lot of flowers. And the scene that I used to see quite frequently was lots of daffodil pickers working in fields, picking crops. We employed about 900 seasonal migrant labourers at that time, picking flowers. Then in the last 5 years, I then moved back to university. So I've done a bit of a circle in my career back to university, where I'm now Professor of Agri-Food Technology at Lincoln. We're very actively involved in agri-food robotics. And one of our big themes is on crop harvesting robotics. And you can imagine where my experiences come from, which is veg harvesting, flower harvesting. So you can see that I've got a lot of interest and expertise in labour handling and labour use in agriculture. And I'm now very fortunate to be director of LIAT, and we operate out of Rhizome, which is the most brilliant, fantastic, beautiful location just north of Lincoln. It's in the old agricultural college of the county of Lincolnshire, and we now operate out of that fantastic campus. We've got a 200 hectare farm and world's first software robotics farm. We're putting a 5G test bed in there in the next few months. So lots of investments going on. It's a very exciting place to be. And so what are the sort of things that I do on my day job now? So I'm director of LIAT, and Andy's asked me to mention a few of the projects. These are just a few of the keynote projects we've got. Our biggest recent thing is Lincoln Agri Robotics. We're very fortunate to get £6.9 million of Research England funding quite recently to employ 30 people to work on Lincoln Agri Robotics. And that's all scales. So that's new professors, new associate professors, new lecturers, new technicians, new engineers, PhD students, postdoctoral scientists, and so on. So we've got a team of about 30, and then some core capital facilities, as I mentioned before, that a 5G testbed going in, which will be the UK's first private 5G testbed for agriculture. I think it's probably the world's first private 5G testbed for agriculture, and that goes in at the back end of this year. So lots of exciting things going on. We've got a full robotic fruit farm. We're working on phenotype field, all sorts of things. Also, we've got a CDT, which is AgriFood. That's the logo on the left. That's 50 PhDs that have been funded by the EPSRC. And that programme goes on for 8 years, and that's joint with University of Cambridge School of Engineering and University of East Anglia School of Computer Science. And those are collaborative research projects in agri-food robotics. And it can be anything from food manufacturing. We've got programs on selective harvesting robotics, machine learning, image analysis, all sorts of programs already going on the way. And what we're trying to do there is train the next generation of scientists and engineers to come into our industry. And say there'll be 50 PhDs that will come out of that program over the next 8 years. So we're very excited by that opportunity. I'm also PI, the EPSLC Internet of Food Things Network, and that's a network to try and support the digitisation of the agri-food industry, and that's all the way from farm through to consumer. We're looking at all sorts of things of how you share data, how you collaborate with data, new technologies to connect data, so blockchain, distributed ledger technology, AI, machine learning to optimize data flows through supply chains, and all those sort of new digital technologies which are coming up. And then I'm also involved in the Ceres partnership, which is University of Cambridge led, and that's an investment fund, and it's investing packets of money of about £250,000 in university projects to try and take them through to impact. And that's we've got programs there on soft-fruit harvesting robotics, blackgrass weeding robotics, new packaging systems, and so on. So lots and lots of exciting projects coming out of the Ceres fund, and that's University of Cambridge, Lincoln, Reading, University of East Anglia, and Hertford's all collaborating around that space. We do lots and lots of industrial research. We have a lot of Innovate UK research going on. We've got programs with NERC, programs with BBSRC, and a range of other sponsors. What really makes it work is the people, though, and that's just the slide at the bottom just shows some of the team. It's about half the team that's working on these programs. We're very interdisciplinary, and we work across all of the University of Lincoln core capabilities. That's engineering, computer science, life sciences, physics, maths, all those science disciplines, business school. And then we collaborate with other universities across the UK and internationally. So it's people that really makes it sing. We've got a very large team now of people working in this space. So that's what we do. Why are we interested in agri-robotics? Well, we think agri-robotics is the transformational technology of the future. And people think of the hardware when they think of robots. And there's a picture of a machine there. I think it's a Case autonomous tractor. But really, the robotics is really about the hardware and the software, and it's the software where we think it's really very exciting, and that's the digitization of agricultural systems through the use of robotics. Why is it a very interesting space for robotics, the robotics community to come in? Well, if you look at my diagram on the left-hand side, the bottom half of it, agri is a great domain for roboticists to get involved in. It's a very challenging environment. So we're seeing lots of our robotics colleagues coming in because there's some challenging areas in autonomy. There's some really difficult things to do with manipulation and grasping. Picking a strawberry, it's unbelievably difficult because you've got to pick it effectively without touching it. It's so soft, and they're in included clusters, so you can't see them. It's the machine learning, the vision is very difficult. Image processing is challenging. And then, of course, if you're going to work in agri, one robot won't do it. I mean, on my old daffodil farm with 900 FTEs, well, that's going to take several hundred robots if you're going to robotize that process, and they all need to operate in a fleet. So fleet solutions are very important. And then you've got enormous flows of data. So things like telecoms, 5G is going to be absolutely critical to the success of these technologies. Now, why are agriculture interested? So we just work in crop robotics, not animals, but there's lots and lots of opportunities in animal systems. But in crops, there's lots of robotics need for selective harvesting. We need to drive productivity in the industry, phenotyping, breeding new crops, using machine learning and robotic platforms, and crop care. So that might be robots wandering around the environment, measuring soils, carbon, detecting pests and diseases, optimizing crops, and so on. So there's a very, very large role for data-driven technologies in agriculture, and robotics will be at the heart of, I think, the next generation of agricultural engineering technologies. So I'm just going to give you an example of why we need robotics, just to emphasize it a little bit more. So this is what I call the known knowns. I want to show you a picture now of fruit picking in 1980. It's a pretty simple process. It's really good, hard-working seasonal migrant workers, typically, not exclusively, but typically, who are picking fruit, and they're picking fruit by hand onto trolleys, and then moving those trolleys up and down the roads. It's quite a hard job. People people call it a low skill job. That's just not true. It's actually a very skilled job. It's just a very low paid job. Got 69,000 seasonal migrant workers who are helping the industry every day through the summer, particularly in fruit picking. Now that's a scene from 1980. What is the scene today? So if you go on a farm today, you will see this. It really hasn't changed a great deal over the last 40 years, but the pressure on the industry now is really very immense. And why is that? So it's quite well known. We've had COVID-19. That's restricted the flow of migrant workers coming into the industry. It hit just before the workers were in the UK, so there's all sorts of problems with movement of people around COVID-19. Problems of COVID seeding on farms are well documented. Then, of course, we've got Brexit coming up, the new immigration bill, where there'll be a restriction, a limitation on the number of workers coming into the UK. So the produce sector industry is under huge pressure. Nobody knows whether from 1st of January, whether the effects of Brexit plus COVID-19 will be additive, or whether the effects of COVID-19 plus Brexit will be multiplicative. So nobody knows what's going to happen, but all the industry know is there's a great deal of additional risk coming on the industry. So how do you deal with that risk? Well, actually, you've got to try and seek automated solutions. By using robotics, what you do, you drive labour productivity. That helps drive profitability in the farms. It protects those businesses, and it also upskills the workforce, and it protects the permanent jobs which are in the sector. So lots of reasons to automate, but very, very challenging, very challenging processes to robotize. So what do we do at Lincoln? And what I want to show you now, if this video is working, is some of the work that's going on at Lincoln in agri-robotics. A short video now on soft root robotics, just to give you an example. And our focus has been on a ROS-driven 4-valve robotic platform developed by Saga Robotics Limited, which is a spin-out company of the Norwegian University of Life Sciences, but much of their development now is done at Lincoln, at Rhizome. And we've operated around a fairly simple robot called a 4-valve platform designed by the Norwegians. So the hardware is Norwegian, a lot of software now is done at Lincoln. And this is a lightweight robot. It's about 150 kilos, it's got a battery life about 8 hours. It's a very modular platform, so it's very easy to adapt and change. You can put tools on top of it, tools underneath it, and cameras and all sorts of things. So initial focus has been on autonomy, so making the robot autonomous, and this just shows the robot world. This is the top screen. This is what the robot's seeing as it's navigating through a polytunnel, and then the bottom screen is the robot in the real world, in the physical world. So most of what we do, we develop in the digital world, and then we deploy in the physical world. And then some of the treatments, this was a great one. This is using UV to control plant diseases, and this is a robot. The same robot, actually, it's a modular robot. This is in tunnels using UVC to control powdery mildew. And this is the robot in Kent. We've got 3 of those robots in Kent this year, going up and down tunnels. Each robot's doing now 9 kilometers of tunnel per night, working very effectively at very, very high precision. So the autonomy of the robot is now very well established, and that's been a result of many hours of coding done by the team at Lincoln and colleagues in Norway and really across the UK. It can be used for fleet support, so using the robot to support fleet logistics. This is an example of what we did in Kent last year. You see a picker on the left calls a robot with an iPhone, and then the robot comes to the pickers to help remove fruit. And the top part of the screen just shows how it's working. So pickers picking away, they press a button, and then a robot will come, take the fruit away and take it to a pack house. That drives productivity by about 20% because the pickers don't have to go up and down the rows with their fruit. Here you go, here's the robots, and they're going back and they're off to the pack house. So that's now reasonably well established. We've done all this work at Lincoln. We've got a robot fruit farm at Lincoln, which is the world's first, which is a full tunnel and fruit setup. And we're now working on picking. This shows one of the options on picking, which is a cup gripper. where the gripper identifies the fruit and then just gobbles it up, and then the fruit then drops into a punnet. We're looking at other grippers as well. It's quite challenging because those fruits are very occluded. The machine learning side of it's very complex. So we're going to show you a video now. This shows what the robot sees, and you'll see the fruit there. It's measuring the size of the fruit, it's measuring the colour of the fruit, determining whether they're ripe, and then it's deciding whether to pick them. But you can also count them, and that's very useful for fruit forecasting. So if you know how many fruit you've got in this size, this is doing it in 3D, three dimensions, every single fruit. And if you can know how many fruit you've got, clearly you can forecast, and that helps manage waste through the supply chain. And this just shows a 3D model of the 3D world, of what the robot sees in the robot world when it sees a crop of strawberries. The system can actually identify each individual fruit every time it runs through. It's quite remarkable. And this just shows several days of data being collected where the systems identify individual fruit, and it's measuring
the first
them
one
daily.
will be fruit counting. What we're going to try and get you to do is count faster and more accurately than it can.
So how does it count the strawberries? What is it looking for?
Yeah, so we use vision. It's going to use this camera right there, looking at the row, and it's going to detect the position of the ripe and unripe strawberries.
This space tech strawberry counting race is on. It's time for me to pit my wits against this robotic rival. 3, 2, 1, blast off. The fruit count is on, and I'm giving it everything I've got.
So what we did there was challenge the country file presenter to actually beat us at fruit counting. It's like a Top Gear challenge. We did a number of challenges on country file, and the robots won every time. So we're getting to a stage where we can we're getting more and more confident about the technology, to the point that where we can challenge presenters on TV to beat us. So that's what we've done on soft route robotics, and it just shows you some of the technology that's coming up. And how have we done it, and how have we worked through COVID as well? Well, most of it, and this links to Lean, has been done for a digital twin. So we work absolutely in a digital world when we design these applications, and this just shows the full robot being simulated in a digital twin called Gazebo. And you can see the robot there. You can see a picking arm there that you've seen in the video. And this digital twin's got a full control system. It's got all the sensors. It's simulating all the LIDAR scans. It's simulating the 3D cameras which are detecting the fruit. It's simulating how the fruit moves if they're touched. But rather like Newton's cradle, you can touch one fruit and all the rest will bounce. So that you can really understand how to detect complex clusters. So we've done this through the spring because of COVID. We couldn't do any physical work, and then more recently we've been out back in the live environment. And this literally was the first run after the spring, working the digital twin, and you can see the similarity between the digital world and the real world. And this is the gripper coming up. It's the first fruit that is found. It's a bit slow because we turned it down, but you can see see it working, and all of that programming was done in the digital twin through the COVID period. And that's the direction of travel for many of these robotic systems. It's digital design, it's lean design, and it's designing before you actually go in the real world. And here we go again. This just shows another one. And here we go. It's picking away, finding the next route, going up, picking away. So that just shows the direction of travel and how this is all being designed. So that's a bit about robotics, and then I just want to reflect on the future and unknown unknowns. We don't know what the future is going to be whatsoever. Clearly, there's lots of concern about use of heavyweight vehicles in agricultural systems. Perhaps it needs a rethink. I'm not entirely certain, because you've got to think about physics of agriculture. The force and energy required for things like ploughing is immense. It's far, far greater than what you'll get out of a standard battery at the moment. So what is going to come into the future? Well, I don't know. Nobody knows. But I think we're going to see a world of smaller robots, perhaps, in agriculture. I think we're going to see medium-sized machines, tractors, And I think we're going to see a world of big machines as well. I think we're going to see a fused world of many, many different technologies. What joins them up, though, is they're all going to be intelligent, interoperable, integrated, and they're all going to be data-driven. So I'm absolutely convinced that the future will be around data-driven technologies in agricultural systems. And that will be new sensors, more intelligence, more precision, and all those sorts of things. What we're going to see is all of these machines working interoperable in a smart way. So finally, what do I think's on the horizon? What's really exciting me at the moment? I think there's three things I just want to reflect upon. One, it's systems thinking. I think we're going to see a world as agriculture moves where we're going to have to think more about the whole system. So how agriculture interacts with the environment, interacts with the energy system, interacts with the water system, and all those sorts of things. And that's going to need engineers to be thinking about system design, complex system modeling, integration of complex machines into these systems. So I think systems thinking you're going to see a lot of that. We're very excited around 5G, particularly private 5G, which is there's a part of the spectrum between 3.8 to 4.2 gigahertz, which is open to private uses. And we think that's where it will come into agriculture, and it will be farms who've got very intense data-driven requirements who put in their own 5G networks. We don't think, I'll be very surprised if 5G is a public service in rural areas because it needs lots of mass, but we can see lots of opportunities for private 5G, and that's fundamentally crucial for data-driven solutions where you've got high bandwidths of data, so we think that's going to be important. And then the other thing which is really, really important is net zero carbon farming. How do we sequester carbon in soils and land? And that's going to need new generations of machines and technologies to help with those processes. So we're very, very excited by the future. It's going to be data-driven. We think robotics will be key, but there are many, many other opportunities around that space as well. So with that, without further ado, I'll hand back to Andy and thank you for your attention.
Simon, that was absolutely fascinating. Thank you very much. I thoroughly enjoyed that. I have got several dozen questions scribbled on my pad, but I think given that we're going to have a live Q&A with all of the panelists on the 4th of November, I might just save one, just ask one, if that's okay, rather than take up too much of your time. I noticed with the strawberry picking, you said you'd turn the throttle down on the robot so it was picking a little bit more slowly, and it's probably a perennial question. I just wondered how fast, or whether the robot strawberry picking was as fast as hand picking.
We're getting that way. What we're building is a parallel robot, which with multiple arms.
Oh, okay.
And that's how we're accelerating. But we think we're more or less at human pace at the moment. Once we speed things up, and then once we go parallel, we should speed it up. And of course, the thing about a robot, it can work 24 hours. In fact, it works better at night than vision system during the day. So we're reasonably confident we will get there. What we don't know though is how many pickers will be available in the future. So it might if the need for speed might be less if there's no other alternative. Nobody knows. It's really worrying.
It's a very febrile time for a variety of reasons at the moment, isn't it? And it's refreshing to be able to see some encouraging examples of where we can go. And as to where we do go, that's another point of discussion in itself. Professor Simon Pearson from LIAT, thank you very much for giving your presentation today as part of the Landwards Conference. We really appreciate your input, and I'm very grateful for your help with this. Thank you, Simon.
Absolute pleasure. Thank you very much, Andy. Yeah.
Don't forget, if you log on to the institution's website, iagri.org, you will be able to see all of the presentations prior to the virtually live panel discussion, again by Zoom, on the 4th of November with all of the panel speakers. So from myself today and from Simon, thank you very much for taking part, and we look forward to seeing you at the live panel discussion. Thank you, Simon.